All right. Sweet. Hello, everybody. I'm Amanda. This is technically like 5 hours of material, so I'm going to try and go through it in 50 minutes so we can all get out of here for lunch. So this is my talk called Disrupting the Killchain. I'm going to go through the Killchain like none of you really know what it is or have ever heard of it before. It really won't affect it if you know it or not. So we'll just start at the beginning of the 7 steps. So I've worked at a MSSP for several years now, providing like logging, monitoring, alerting services to anywhere from like 20, 30 person companies all the way up to like Fortune 50 companies. They all have different needs. They all have different things that they want to monitor for, but a lot of the same kind of overtone, and many times like the C-level executives always bring up this kill chain. And it's just a buzzword that they've always wanted to use. So what the intrusion kill chain is, it's sometimes called the cyber kill chain, and a lot of people make fun of it in InfoSec. But what the actual definition is a model for actionable intelligence when defenders align enterprise defensive capabilities, which is what I do, is all the defense side, for the specific purposes an adversary undertakes to target that enterprise. So targeted attacks, APTs, whatever you want to call them. It's composed of 7 different steps, and Lockheed Martin is the one that kind of came up with these 7 steps. First one is recon. So it's when an attacker will research, do that OSINT that Matt was talking about earlier. They'll select targets, crawl internet websites, LinkedIn, looking for email addresses, looking for any kind of open source intelligence, and that's if they're coming from the outside, right? You can also do recon if they're already on the inside of the network at the beginning of the attack. Second step is weaponization. That's an automation of some kind of tool. So it's when they put a Trojan in like a PDF or a Microsoft Office document, or create a macro, that kind of stuff, and actually create that weaponized deliverable. Third step is delivery. That's when they actually transmit that deliverable to the target. Usually in the form of like drive-by downloads, or like the USB drive that they leave in the parking lot, all that kind of stuff. Email attachments. Number 4 is exploitation phase. So after the payload's delivered, that actually the exploit code is run on the machine. It'll either target an application, the user themselves, and it will execute the code. Step 5 is installation. Installation is of some sort of tool that's going to allow them to maintain persistence in the environment. So it could be like a client server type setup that they have, but the installation is of number 6, which is command and control. So if an attacker is attacking you, they don't want to just have one foothold on the inside of the environment. They want to have as many as possible, because if you find one and shut it down, they don't want to have to start all over again. So command and control is going to be kind of an automated process that they have some kind of server on the outside, and their clients are now potentially the inside of the network on desktops, whatever. And 7 is actions on objectives. That's the end. That's where they've gotten what they've needed, whether it's data corruption, exfiltration. They can use the endpoint as like some kind of botnet or hop to do whatever they want to, and maybe start from step 1 and go all over again. So what I like to do with my customers is come up with common threats that they worry about. One of my most common questions that I ask like our customers is, what do you worry about at night? Whether it be from your intellectual property being stolen, or maybe it's like a customer database being breached, whatever would really, really, really screw them over if it got in the hands of somebody malicious. That's what you need to worry about. So some of the things that are top of their mind. So according to, it'd be last year's Verizon DBIR, 88% of breaches fall into 9 different categories. Cyber espionage is number 1. Usually this is like state-sponsored actors, and the targets are larger companies or companies with political leanings or something like that. Second is DOS attacks. This 98% of DOS attacks happen towards very large enterprises. 3 is crimeware, which is ransomware, malware, all that kind of stuff. It's climbed from the 22nd most common of malware up to the 5th in less than 3 years. And really, this is a lot of what's on the top of people's minds. I've had so many people get ransomwared, and so many things they could have done to prevent it. And it's definitely something that happens a lot. 4 is insider privilege and misuse. So like a rogue admin, that kind of stuff. And then what? People like all of you back there. Yeah. And then the rest of them are lower in priority usually. So web app attacks, miscellaneous errors, the kind of one like the Amazon mistype that brought down, all of their S3 buckets on the East Coast. Skimmers, POS intrusion, and then everything else falls into a smaller percentage of attack. So what I wanted to do is break down the common threats that my customers were worried about into things they could actually do. That cyber kill chain, intrusion kill chain, people like to talk about it a lot of the time and have absolutely no idea what to do to defend at each step. So what I did is I actually made this gigantic spreadsheet that has like ransomware for a tab, and it has insider threat as a tab, and it just breaks down kind of what happens or what can happen at each stage of the kill chain, and not only what you can do. Let's see here. So the malicious action, so what happens at each stage. What you can do is a defensive mitigation. A lot of times there aren't defensive mitigations that you can do, but there are other things that you can do, right? How easy it is to deploy those defensive mitigations, and then monitoring and specific alerting. The 3 things that I'm probably the best at is the defensive, the monitoring, and the alerting. It was harder for me to kind of learn what happens at each stage of the attack, but that's why I have a bunch of red teamer friends, because they can actually tell me, if I want to get this data, where do you start? And then I would work with them and find out, okay, well, you do that, but I can do this to block you. And then if that doesn't work, you do this, and I can do this to alert on that. And we just kind of went back and forth to figure out, how ransomware works and all that kind of stuff. So we could kind of build this framework that people can just, in kind of like plain English terms, look at and be able to actually do something with. Okay. I could probably show you the spreadsheet, maybe. Well, I'll wait till the end for that. So no 2 networks are the same, whether you've been an attacker or a defender, whether you've been studying it, whether you've been setting it up. I've never come across 2 networks that are the same. You defend them differently, you attack them differently. And this is the Microsoft version of the attack kill chain. They did these little loop-de-loops instead, because a lot of attacks don't actually fit into the Lockheed Martin kill chain, because it's not, an attack isn't a straightforward 7-step program. Some of them do fit into it, and you can kind of shoehorn them in and kind of figure out, okay, maybe this one only has 5 steps, or maybe this one has 9, and break it out like that. Then Microsoft instead did this little loop-de-loop where they have this low privilege escalation lateral movement cycle, and then they have like the more evil roller coaster with the little devil guy, which is interesting. And this is high privilege. Now the last one, they say this could take months, but in all actuality, it could take months, it could take hours. just depending on the target. Same thing with the high privilege. When they're already on the inside of your network, it says it could take weeks, but honestly, I've seen it take 60 seconds. It definitely, the time doesn't really matter, but it's just the idea that it's more of a cyclical type of attack a lot of times. So what I did was I broke this talk/training down into, I think I have 4 different use cases. The first one's ransomware, and I know I'll be able to get through that in the next 45 minutes, so we'll try and get through the other ones too. And as we go through all 7 steps, like I said, it might not all fit. So recon, right? Recon's the first step in the kill chain, and then these are my 5 different things that I broke it down into. I definitely don't have a slide for every single one of them because some of them are boring and some of them you can't really show in a presentation at all. So I kind of just skip around. Just know that that's the step that we're on, and that's the part that I broke it down into. So even before any kind of incident is happening, a lot of people think that you can't really do a whole lot at this recon step. So the most malicious action is them looking for email addresses, technologies used. They can create like a dossier on your organization or specific people to try and attack them and create more advanced targeted attacks. These are a couple of examples that I had used. I had participated in the DEF CON SECTF, which is super fun. If anybody goes to DEF CON, I highly recommend not only participating, but going in and watching them run this. They have one now at DerbyCon too. But what they do is you sign up for it. They give you a company. So my company that I got was Frontier. And you basically find all the OSINT you can about this company, and they give you a list of like 20 different things that you need to find and create a report on. This was some of the stuff that I found. So like plain HTTP logins to their firewalls. So that's the F5, could be a load balancer, could be a firewall. Their organizational like employee logins. And then this picture of this poor guy has been on lots of slides of mine. But this was on the Frontier's Facebook page. And you could plainly see the type and model of computer they were using. The fact that you had, Windows 7 with Adobe pulled up and what browser he was using. And there were a couple other pictures of like their badges and stuff like that, all on their employee Facebook page. So what can you do as a defensive mitigation? A lot of people say nothing, but really there is a lot that you can do to kind of put canary in the coal mine type stuff out there. If you control anything to do with, that part of your organization, you can create like a fake LinkedIn profile. You can create fake emails. There's a website called Canary Tokens that you can create tokens for pretty much anything. You can create, and it will alert you that these things have been either used or gathered or exploited or whatever. You can have like Canary SQL databases or application servers, or really they have a very large amount of different things that you can do on that. So now we're on the delivery step. As we all know, most ransomware is distributed through means of phishing, sometimes targeted, sometimes not, or could be just like a mass email. But there are several defensive mitigations that you can do at this step. One that I really highly recommend, and I don't really see a whole lot of people do, is assess what types of attachments that you need, or file types, file types that you need in an organization. Not everybody needs to run JavaScript. Not everybody, you might not use screensavers. Not everybody should. All of these are could be very potentially harmful file types that you can actually stop. And I have a walkthrough on how to stop those. So there's, what do I have? 5 other things that you could do. You can implement scanning for macros coming from the outside, or just block macros altogether. And I have a walkthrough on that too. There's things called blacklists and gray lists that you can implement for your mail servers. You can install the idea of trust but verify to your users, because we all know humans are one of the biggest weaknesses in an organization. And do things like ad blocking, blocking of adding extensions onto your browsers. There's a lot of stuff that you can control on an endpoint to not have to worry about it as much. So this is going to be a walkthrough on how to change the default application that opens malicious files. In this case, I'm going to change it so group policy controls a JavaScript file, and it's going to open it with Paint, I think, instead of actually running the potentially malicious JavaScript code. We'll see if this works. Play. Is it going? All right. Can you actually see it? Kind of? All right. So this is the deployment image service manager tool in Windows. I'm exporting the default application associations on the server, and those actually go into like a plain XML file. And you can edit this XML file to open up any extension with any program that you want. And we're going to actually force the users to open it up with whatever you want, right? I can't see what it's doing. I think I'm saving it. Yeah, so now there's a default applications.xml. And you actually, right now it's just in an XML file. It hasn't actually done anything. So this is group policy, where you can set pretty much all your Windows settings that you ever want to set. I'm creating a new group policy object, which not really super related to this, but there's 2 different default GPOs that come with Windows. Never edit them, just as a best practice thing. So in here, I think I have that path written down, maybe. Yeah, so computer configuration, policies, administrative templates, Windows components, file explorer, and then you can actually point to where this XML file is at. It says set a default associations configuration file. And right there, it gives like the example of what the command is that you actually have to run. So we'll enable that, and it kind of tells you, you can point it to wherever you want, but all I did was move it to that path. I think I have cool music with this too. It makes it a little bit more entertaining. So there's already one there. All I did was paste over top of it. And there's the new one. I'm going to create a fake malicious JavaScript file. And you can see it's going to open up with Paint instead of the actual JavaScript. It thinks it's a bitmap image instead of the malicious file. That will only work when you do it this way on the computer that you put it on, or if it's a domain join computer, right? Because it's pulling all of that information from Active Directory. So that's one thing that you can do to kind of block malicious file types. You can also flag different things. So two known things are that screensaver files over 22 megabyte and JavaScript files over 15 are mostly known to have to be ransomware files. And you can also block them with mail filtering. So now we're on the exploitation phase. The endpoint will download that malicious file, whatever it may be, JavaScript, Microsoft Word with macros, blah, blah, blah. Those can either come from an attachment or drive-by download. As we've seen more recently, there's actually been processes that don't really need the macro. It can just like, Word can spawn a process outside of itself, and there are different things that you can do to block against that. But you probably, at that point, you should have an endpoint solution that says, hey, my Microsoft Word document shouldn't be running PowerShell. And we can disable macros via group policy as well. And let's see here. There's different like admin packs that you can add to group policy for a barrage of different things. One specifically that I always like to add is the one for Microsoft Office. It will give you a whole bunch of security settings and additional settings for all of the Office suite, right? It will give you Word, Excel, PowerPoint, all that kind of stuff. And that's not there by default. So, blocking macros. See if I can see it again. So these are those custom files that you have to add to have the correct settings show up in group policy for Microsoft Office. And they show up right there, all those Microsoft whatevers. And you can add all the ones for the different versions and different years and stuff. So under Word options, there's actually a whole lot of different security things that you can set per application. But here in file block, is it file block settings? Yeah. Maybe. Or maybe I'm just showing different things. Oh yeah, there we go. Block macros from running in Office files from the internet. So you could totally create and sign your own Office macros internally. I know a lot of people actually do that and still don't have the set. But yeah, you just go through and enable that. Which is very, very difficult to convince people to do. Just because not only one thing that you can do with group policy, say like your accounting department definitely needs to use macros in Excel because they work in Excel all the time. Obviously macros in Excel make a whole lot of sense. You can make it so that specific group of people can run macros, and then you can actually identify the people that need to do it and give them more training on, hey, I probably shouldn't be downloading this file from the internet and running their macros. Another thing that you can do is monitor proxy logs for unexpected file retrievals, like going to an IP address and JavaScript file is the first file that they download. Different IDSs have rules for this kind of stuff as well. This tool is called Floss. It's F-L-O-S-S from FireEye Labs. It will actually deobfuscate, which is always a word I have problems saying, the strings that ransomware uses, because it uses these huge long strings that it obfuscates to, talk to the command and control servers. Well, this tool can actually detect some of that. Now we're on the installation step. Unless any of you feel like watching me encrypt myself with ransomware, I'm not going to do that right now. We're just going to pretend that we've ransomwared ourselves right here. Ransomware variants like CryptoWall.
Presentations always have so much promise that you
Sorry. I have a lab at home with something ransomware, but I can't get to it right now. But they'll actually use the built-in Windows Crypto API to start encrypting the files, which is another thing that you can alert on. And what can we do at the installation step for defensive mitigation? At this point, you're pretty far along, right? They have already gotten the ransomware all the way to this step. It started encrypting the files. Obviously, backups permanently. Like make sure your backups work. Make sure they give you all the information that you need. There's different things called like RPO, RTO, which is recovery point objective, and recovery time objective, which are completely like things that you want to work into your backup NDR plans. There's things called file system firewalls, which some of the next-gen AIDE endpoint protection things have started to do, which will block certain programs from spawning others. You can also have a portion of your IR set aside, depending on if you have like cyber insurance, or if you don't, you can actually just buy some Bitcoin, because sometimes you actually have to pay the ransom. I never recommend paying the ransom, but if you have to, you have to, right? You didn't do your due diligence prior, you don't know what's on that machine, or you know what's on that machine and it's not anything that you had backed up. Sometimes you just have to pay the ransom. What can we do for monitoring and alerting? So this is an example of the Windows Crypto API spiking when Cerber started encrypting the files on the file system. And now we're on to command and control. What it does at this point is the ransomware transmits the decryption key to their command and control server on the internet. If any of you know what a DNS sinkhole is, this is a great defensive mitigation to do at this point. This is kind of what a DNS sinkhole works like. So you have your end device, right? And a normal search for google.com, which your internal DNS thinks, okay, that's good, that's a good domain. I'll allow that out to the downstream DNS servers. But if you search for, have like a ransomware looking for XYK35 blah, 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 blah.com, that's already shown up as one of the listed bad domains, it'll just send you nowhere, right? It can send you to localhost, it can send you to an internal server, it can do whatever you want, but the point is the computer itself doesn't actually end up going to that site on the internet, or the application doesn't end up going to that site. I've seen this work in not necessarily a ransomware case, but it was a phishing case that we had at the one hospital that I worked at. It was it didn't automatically block it, but we found one of the pen testers that we had hired phishing us, and the IP address and domain that their phishing was going to, like the DNS address and everything. After 7 minutes, I think it was, because we actually, we had user training and they knew who to report it to. After they reported it to us, we were just able to add that to our DNS sinkhole, and then anybody else that got any of those emails, it just didn't go anywhere. After that first person, you're able to kind of use that in your IR, live IR playbooks. So this is another potential monitoring thing you can use. A lot of times I have customers that want to alert on any threat list activity, which is a horrible idea. Threat lists are great for specific reasons, if you can identify those specific reasons. But there are a crap ton of IP addresses on these threat lists that are not threats. Just the other day, there was a company that added all 169.254 addresses to a threat list, which really can mess up the inside of your network. As well as, like, I've seen people add all RFC 1918 addresses to publicly, because anybody can submit stuff to some of these threat lists. And then all of a sudden you're getting, 5 million alerts on threat list activity when it's just the inside of your network talking. But these are some of them that I really like to use. There are like Tor exit nodes, but you can kind of massage threat lists to actually have to do with threats that you're worried about. You don't just like blindly implement all of them. And this is on SANS. Another one that SANS has is like a few lists that they're super sure about. So they have different rankings. Like all of these IP addresses have been specific known threats for the last 5 years. We know that you're safe blocking these. Sure, add those, right? That's usually never going to be a bad call to add all of those. But you have to have a certain sense of surety when you do all of that. These are called DGAs, and ransomware uses these. It's a domain-generated algorithm. That way, ransomware people don't have to like set up one domain, and as soon as somebody finds out that that's the domain they use, everybody blocks it. They use these. I mean, nobody would go to those, right? Or I hope not. And there are actually specific like IDS alerts and stuff that can alert on this type of activity, right? Because you're never going to just see somebody go to a 30-character domain name in Russia. And we're at the 7th step in the kill chain. A lot of people, I'm sure, have either seen a picture of the screen like in action, or at least seen a picture of it. The ransomware has started encrypting everything. This is the splash page that you'll get for one of the variants. Sometimes you get like a text file giving you instructions. It's usually like a countdown timer, instructions on who to call or who to contact to get your stuff back. And what can we do for defensive mitigation? This is one of my favorite things to do. It's called honey directories. So what ransomware does when it starts encrypting your files, a lot of the time it will start at directories and we'll do it in alphabetical order. In that alphabetical order, it starts at $ whatever. That's why a lot of times when you see ransomware start encrypting, the recycle bin is the first one, because this $ recycle bin is the first one listed in on your C drive. So there is a PowerShell script that I did not create at all, and the site that did create it and the people that created it seem to have just disappeared from the internet, so I can't really give them credit. So what it does is it creates a mount point on the C drive that is just $, and just like pointers to the rest of the new fake C drive that it's created. And it will allow you to navigate through those directories up until the character limit of a path in Windows, which is 256 characters. So you can go like, actually click through these and it'll be like $, $/$, $/$, all the way up until 256 characters. And all of the other links that are in there look like copies of the C drive that aren't. But you could actually navigate through those. So it kind of gives as an early warning detection system for ransomware. By the time it gets through all of those, you may have 5-10 minutes, but that's 5-10 minutes that you didn't have before. So that is this. So this is the PowerShell script. And that's how fast it runs. And now my C drive, I have this $, that you could just go into, and it's just everything forever. So I'm going to actually go in and show you how to create a log that shows somebody accessing this. Now, you could have definitely some false positives if you have a user that just gets curious, like, why is there a $$ directory? Okay, but honestly, that probably shouldn't happen super often. So in here, you just set auditing to everyone. This isn't an access thing. This is just the fact that you want to create logs on anybody accessing this file or folder. And into group policy again, we actually, starting with 2008 R2, Windows Server, they created these like way more advanced logging options that you can have. And we're going to go in and turn these on. So advanced audit policy configuration is the new one that they added. Under audit policies and object access, I think, yeah, object access. I'm going to audit our file system, and we're going to audit for success for access. And when you make group policy changes, when you want them to take effect right away, you have to do a group policy update. This normally happens randomly throughout the day, in intervals, or during reboots. Now I'm going to access this file and pretend to be malware, going through and trying to encrypt stuff. And I hate Windows Event Viewer. And see right here, you can see an attempt was made to access an object, and the object name $$. So in a SIM or any type of logging solution that you might have, you can say, all right, well, if I get this event ID happening, you could try it all first, right? Anytime you do any kind of logging solution, there's a lot of tuning that's involved. So you can start with, I want to see it anytime this happens. And then if you get a crap ton of those because users are going in and clicking on it all the time, you want to say, I want to see when this happens so many times in 30 seconds, and then alert on that. Here we can see an example of that in Splunk when it was actually set up, right? So can anybody tell me when the file started being encrypted? Crap ton of those event logs come in. And we have finally gotten through the first use case. So we have like 10 more minutes before we have to go to lunch. I think it's two more use cases. Do you want to learn about data loss and theft? Oh no, I have 3. Insider, like privilege misuse, or OSINT? Any preferences? Insider. Insider? All right. Just ignore all this. There we go. Lateral movement and privilege misuse is what it is. Okay, so none of that makes sense because we didn't go over DLP. So first step is recon. Has anybody ever heard of Bloodhound? Right? So Bloodhound is a tool. It used to be just a PowerShell script and like database stuff. Now they've turned it into a full-blown application that will enumerate Active Directory. So you can run it, and it will give you this huge all these printouts, or it will create this this database structure of what actually Active Directory actually looks like. At this point, and this is why it's in kind of a lateral movement use case, is because by the time Bloodhound is being run, they're already on the inside of the network, right? They're still doing recon, but it's a little bit later. It's in that second, more evil loop-de-loop that Microsoft created. So the malicious action is things like Bloodhound. You can also use other tools, WMI, SNMP, anything that's native in the environment to use to gather more information on the target. And this is Bloodhound running. It's just a little PowerShell script. Oh, I don't think you can see it. All right, well, we'll skip that one because I also cover it later. So let's see here. One of the first methods of attack during the recon phase is something called, you can use Responder, or there's a couple other tools I think that do this now. But it's basically spoofing LLMNR or NetBIOS requests across the enterprise. So this is kind of a little diagram of how it works. Basically, the little victim guy over there, he goes to search for like a printer or a file share, and they type it wrong, right? They'll be like / my test server 1, but it doesn't really exist out there. That still creates some broadcast traffic, and it happens over a specific port, and it's either NetBIOS or DNS or LLMNR, which is link local multi-name resolution. Is that right? I always forget that one. But those are things that you can actually shut off in an organization. They're kind of deprecated standards that are out there. You should be using DNS because it's a little bit more secure and it doesn't do this whole thing. So, with Responder, oh, I thought I had a thing that showed Responder running. Crap. Invade, thank you. So I did have a video on this running, but we also don't have much time for that. So basically what you do is, you know, that victim box tries to go to it, and the attacker can actually say, I am test server 1. And it'll just capture your Windows credentials. Super easy. And this is supposed to be the walkthrough on how to turn that off. And if you want any of this stuff later, I have like videos on YouTube, and you can have the slides or whatever. I have like specific step-by-step instructions on not only how to do the attack part, but also how to prevent it. So there's a crap ton of defensive things to that you can do in this type of recon phase. Obviously, good passwords. This is kind of just like some simple math behind what a good password is. And a good password doesn't have to be 15, 20 characters. It just has to be long or complex, right? You actually have to think about the math behind it. One of the huge struggles, again, in enterprise is password policies. If you can get them to do anything but the first two, you know, it's a little bit more towards the security. Microsoft also has fine-grained password policies, which are okay. It allows you to set different password policies for different people. They used to have a thing in Windows 2000 that they got rid of, but it would be a custom DLL that you could write, that you would say, all right, well, I work for Acme. I don't want any of my passwords to contain the word Acme. They got rid of that, so Windows doesn't do that anymore, and you have to have a custom auth solution. Right? Like, I tried to actually write the DLL to make 2008 do it, or 12. It didn't work. Another thing that I've heard that really trips up pen testers is not only two-factor auth coming in from the outside, but two-factor auth on all the important stuff internally. I've always wanted to go a little bit further into blocking specific passwords. There are people that try and do like Active Directory add-ons for their like help desk or whatever that may give them that extra step of security when it comes to choosing passwords, that kind of stuff. This is actually an example that I ran into. I had a customer wanting to put this data in Splunk. This was their custom, well, this was an application that they paid for their help desk to be able to reset usernames and passwords. But it logged the username and password in plain text in the log file, and then everything just showed up in Splunk, and we could tell what all their passwords were being changed to. And so could anybody that could read that log file. It was in Windows Event Viewer, it was in the text log file itself. It's ridiculous. So that's one thing that you should definitely pay attention to when trying to come up with better password solutions. Okay, so hopefully you can see this Bloodhound demo. If not, I'll just open it up in YouTube. But this is going to be actually running it, and then, or maybe not. Maybe it's not the running. Maybe it's the alerting on. Oh yeah. So this is more fine-grained audit policy settings. You can turn on all PowerShell module logging. So anything that's run in PowerShell, any command that's typed, you can actually log that in Event Viewer. Same thing with the command line. You can do command line logging. And that's something else to do with logging. Oh, yeah, include command line in process logging. Those are the CSVs that came when I actually ran the Bloodhound PowerShell script. Son of a bitch. Hold on. We'll get this. Fast forward through all the things. Oh, why can't you see it there either? Oh, that's disappointing. Hopefully we can see it in Active Directory. Oh, maybe you can see it, kind of. Well, it's super small, but that's part of it. That's invoking Bloodhound. And then it's running and populating all of these CSVs with who the admins are, who the groups are, what the trust permissions are, all that kind of stuff. And then in Event Viewer, now there's a crap ton of different event viewers because all of that audit policy settings have been enabled. And under Operational PowerShell, you can actually see, ta-da, that Bloodhound script was run. And you can alert on whatever you want. You can alert on super long PowerShell commands being run. You can alert on really anything that you want that you think might be an issue. For this? Oh, for me? I don't do PowerShell stuff anymore. Oh, really? For 3, right? Didn't it start at 3? Or yeah. Okay. So, where's my mouse? Okay. So we're at weaponization. How much time we got? I'll just run through this real quick. So the most common thing that you can do at this point is like application whitelisting. Some people try and do blacklisting, not only with their applications, but also with their firewalls, and say, I just don't want these 5 things to work. And that's a horrible idea, because then everything else will. Just had a very frustrating conversation with a customer the other day about that exact thing. Exploitation phase, that's where all the action happens. Things like Mimikatz, pass the hash, sticky keys, credentials being harvested, all that kind of stuff. You can pull it out of memory. And that's a big chunk of the stuff that we have to try and defend against. The primary defense against Mimikatz and other privilege escalation is limiting who has local admin and who logs on with admin to all of the things. A couple other things that you can look into: SMB signing. I lost my mouse again. There we go. Privileged access workstations, also called jump boxes, right? So I don't want everybody to be able to SSH to all my switches. I just want this one box to be able to SSH to my switches, and that's the one that my admins are allowed to log into. You can lock that stuff down a lot more, do a lot more segmentation to kind of protect against this phase. Another thing called LAPS, which is the picture. It's the local admin password solution. I've never had anybody ever actually implement this, but what it does is it actually changes automatically all of the local admin passwords on the domain. It's just a random string. That way, once an attacker has a hash and a username for one box, they can now not use that on the rest of them. Because a very large theme in enterprises is they'll just image a workstation, and that admin and password is the same across everything. Yes. It's a gigantic pain in the butt. Things to note when using LAPS that I did not know until I actually implemented it once is that it will change your domain admin username and password. So thank God I had VM backups because I could no longer log in anymore. And then we're on to the OSINT one, which we are going to skip because it's 12 o'clock, and I'll just go past all this stuff, and if you guys want it later, you can have it. Tabletops, blah, blah, blah. And then that's me. I'm Amanda. Listen to my podcast. Buy my book. Follow me on Twitter. Yes, Bill.
Are you willing to share those for academic purpose?
Once I finish them, yes. I'm writing a bunch of tabletops for things, so that's my next project. Any questions? I know I went through a crap ton of stuff and also skipped a lot. Yes, Bill. All the stuff we yes, it will. All the stuff we covered will work on a Mac. It will work on your Apple Active Directory server. All right. Well, thank you.